Hi everybody, Mary here, and we're going to start talking about how do you ionically bond with transition metals. Now here's the good news. The process is exactly the same as it has been when we were dealing with main group representative metals. But the thing with transition metals is some, not all, but some have more than one common ion. How do you know if they've got more than one common ion? Well, if you look at the periodic table I provided you with, in the box for that metal, there are some little charge numbers right there. For example, next to iron, it says +2 and +3. Now, those are the most common ions produced by iron. Sometimes it's +2, which tends to give a bluish aqua color, and sometimes it's a rusty red, which gives a rusty red color with a +3. If your eyes are good, you can see that the 3 is a little bit bolder and bright and darker. That means that is the most common form. And when you're looking at this periodic table, if you need a magnifying glass or something like that, use it because this is written really tiny on those periodic tables. So how do you know? Well, the good news is you're going to be told most of the time. But I want to show you how do you figure this out on a periodic table if you're dealing with one of these wacky elements. Copper is another one. Copper can often give us blue or green compounds, copper 2, copper 1, and on the periodic table, the 2 and the 1, can you tell which one is going to be more common? Yeah, that dark 2, copper 2 is blue, and those are going to be the preferred way of bonding. Lead can be lead +2, +4. Again, color change is an indicator often that there is a change in bonding. So that's kind of nice. It's a really cool visual clue that we can use in chemistry. Chemists indicate this in the names of compounds with a Roman numeral. So, for example, this iron chloride is iron 2 chloride. And the 2 tells us that in this compound, this is iron +2. That is how it is bonded. Now there's another form of iron +3, that ion, and if it was bonded with that, they would have written iron +3. This copper 2 sulfate compound was made using copper bonded with a +2 ion, and the other form is copper +1. So this is a very convenient way of doing it. You don't have to guess. The Roman numeral just tells you the ion number of the metal that's involved. But for you and I, this is the important part. If the metal can have more than one ion, you must include that Roman numeral in the name. That's a big, big, big idea, important thing. So let's go through a couple of these. Let's talk about iron 2 and oxygen and iron 3 and oxygen. So if I have iron 2 and oxygen, most common ion produced of oxygen is -2. Metals written first, one of each, FeO would be the compound. How do I name it? I would name it iron 2, Roman numeral 2, to indicate that's the ion I'm working with, and then second non-metal ion ending changed to IDE, iron 2 oxide. If iron 3 bonds with oxygen, it would be iron 3 and oxygen, again, -2. This time they're not the same, so we crisscross. Fe, the 2 comes down, O, the 3 comes over, Fe2O3, and the name would be iron 3, Roman numeral 3, to indicate that's the ion and oxide. And I included a picture of iron 2 oxide, iron 3 oxide, because I really want to hit home this idea. They're not the same compound, different physical, different chemical properties, different chemical formula, different chemical name. So it's really important you get this right. All right, hit pause. Try coming up with a formula and name when copper 1 and 2 bond with oxygen. All right, let's go through these together. So copper 1 and oxygen Ew, oxygen's negative, so this is going to be Cu2O, and it's going to be copper 1 oxide. This is Cu plus 2 oxygen, so this is CuO, and this is going to be copper 2 oxide. And why is that 2 there? The 2 is there because that's the ion of copper. And again, I included pictures because I really want you to understand this is different compounds. Now, to make it a little more tricky, there is an old-fashioned way of indicating the differences between metal ions. And the way this was done is the Latin name was followed by an ending, and the ending indicated if we were using the larger ion or the smaller ion. The larger ion ended in ic, and the smaller ion ended in us. And the way I keep this straight, and put a star by this because it works, the big one is the icky one. So let's take a look. Iron 2 is fair us, and iron 3 is fair ic. Whoops, Mary's got a boo-boo here, so I'm going to fix this. Copper 1 is the smaller, so it should be the us. So copper 1 is going to be coop Rus, and copper 2 is going to be coop Rick. Now, why do we even bother with this if this is the old-fashioned system? It's common in medicine. You go to the drugstore, you get prescribed a medical medicine of some sort, you're going to see this. And I would be remiss in not including this information. I also realize a lot of people who take this class are looking towards a medical career. And if you hear about cupric sulfate and you go, I don't know what that is, I've never heard it before, well, that's my job to help make sure you've heard of this before. So let's show off how incredibly smart you are. The active ingredient in many, many toothpastes to actually help prevent tooth decay is stannous fluoride. Well, stannum is the Latin name for tin. And I think they use the Latin name because tin fluoride sounds like kind of something you don't want to put on your baby's teeth. But let's figure this out because you're so smart now. Okay, stannous. Stannous ends in us. Is that the big one or the little one? The icky one's the big one. So we'll take a look at tin. Here's our tin on the periodic table. The icky one's the big one. The us one is the little one. So this is tin plus 2. So Sn plus 2. Fluoride from our periodic table is group 17 element. That's going to be -1. So you can now figure out that the chemical formula is going to be SnF2. Do you feel smart? You should. That's pretty nifty stuff. Now, how do we rewrite this old-fashioned name, stannous fluoride, with the Roman numerals? This is now going to be tin 2, because that's the ion. 2 plus 2, fluoride. Tin 2 fluoride. You do not put a plus or minus sign in with this Roman numeral. It's a metal. We all know metals have positive ions. Try this. Cuprous bromide. Hit pause. I want you to, from the name, come up with the formula and try writing the Roman name. Give it a try, then we'll go through it together. Okay, cuprous. Okay, copper can come up with a +1 or up with a +2. Cuprous, so this is the little one. Cu plus 1. Bromide is a -1. So the formula is going to be CuBr. And the name is going to be copper. We put the ion number is the Roman numeral. Copper 1 brom. And the second ion ends in IDE when we ionically bond these binary compounds. Okay, smarty pants, try this one. Gold doesn't make a lot of compounds, but when it does, it tends to make sometimes really pretty red stuff. So auric oxide is a gold oxide powder. Use this information and your smarts come up with a formula and the name. Hit pause, give it a go, then we'll go through it together. All right, or ick. The icky one's the big one, so this is going to be gold in the +3. Oxide means oxygen. Oxygen is -2. Crisscross, there and there, so AU2, O, 3 comes down, 3. Excuse me, I'm going to cough. Tickle on my throat. There we go. AU2O3, Roman numeral. This is going to be gold. And 3, 1, 2, 3, oxide. One of the things that makes this whole naming thing challenging is that you only mess with these Roman numerals if the transition metal has more than one common ion. But some do not have more than one common ion. So let's look at the section of the periodic table. If I look at copper, it has a couple ions. If I look at iron, it has a couple ions. If I look at nickel, nickel has a couple different ions, and so does cobalt. But I'm going to change color pens here. If I look at zinc, zinc has 1, aluminum has 1, cadmium 1, silver 1. So if you are dealing with a metal that only has one way to bond, here's where it gets tricky. Do not include the Roman numerals or the old-fashioned names in the names. So if you were going to bond aluminum and oxygen, it would be aluminum. Aluminum is a +3. Oxygen is a -2. You crisscross those, you'd end up with aluminum. Oh, you can't see that red, can you? Or that green, can you? This would be aluminum 2O3, and the name would be aluminum oxide. No Roman numerals, no ions, no icks and us's, just straight. So you only use those extra Roman numerals or the names if you're dealing with one of these that has more than one common ion. On the study guide for the week, there is practice. So please, please, please practice and then check. Are you getting the right answer? Then practice and check. Because on the quiz for the week, you're going to have to do this. And this is a skill that we're going to use later on when we start writing chemical equations. So you can do this. It's not that complicated. You just follow the steps, and you just have to watch out with these crazy transition metals. All right, we'll see you later. Bye-bye.